Hi, Chris Kuzma. We're continuing with our implementation of partition by creating a toString method, and it takes no arguments. Oh, no, I'm wrong. ToString is going to take an array of integers. All right. And like I said, I'm certain there's a library function that prints an array, but we're just writing it here for the exercise. And it's going to be for int e in array, retval adds a space and e. Okay, and then we're going to return retval. And let's add to that. We're going to put a close square bracket at the end of the string that we return, and open square bracket at the beginning of the string. And that looks to me like that's that. And so let's zoom out on this and see whether or not this compiles and runs. We have an error. Oh, yes. So when we do our test cases, then we increment the variable pass or the variable fail. And those variables, the way that I usually do it is I make those variables fields within the class. So that's what I'll do. Generally speaking, it's good to put fields at the beginning of your class declaration, of your class definition. Int pass fail. Because they're primitives, they will initialize to 0. Because they're fields, we don't have to worry about the compiler complaining that they're not initialized. So that should be sufficient. But they need to be static variables. And so I make them static. Now when we run, what error do we get? Cannot find symbol actual. Actual? Really? Variable actual. Oh, that's surprising. I must have misspelled it somewhere. Oh wait, now where is that? Oh, and retval was not defined either. So cannot find symbol variable actual. That's on line 27. So we look on line 27. We see that actual is being printed. I thought we had actual. Oh, my actual is not actual. It's going to be AR. AR is the actual array. No, wait a minute. Expected is expected. See, I got confused. Expected has the name expected. The actual has the name AR, if that makes any sense. So the value we expect is expected, which is this 3. The value that we actually have as a result of invoking the partition is what's in whatever is in AR, which does indeed start as 3. So we wouldn't expect that to be erroneous. Now, what other error do we have here? Retval did not get defined. Right, in the toString method, I failed to define retval, or declare retval. So that's going to be a string, and I'll initialize it to be an empty string. And now that looks reasonably promising. I don't know what other errors I have here. They might all have been addressed by now. Yep, hello world works out. That's fantastic. We in main do call partition test 1, but we never, and apparently it runs without error. It does not print out an error. That's good. Well, it would be nice if we were to verify that we in fact can get an error with the partition method. And so we could just do something like make expected before. And when we run, we see indeed we got the error expected for. And the formatting of the arrays printed out is a little funky, but it's not too bad. So I'm content with that. So that suggests things are okie dokie when it comes to the partition test. But of course, at the end of our main, we want to print the passed and failed counts. Okay, and when we run that, passed 1, failed 0, fantastic. Give myself a little space into there. Okay, so that's lovely. We pass a test that detects that partitioning did nothing at all. But that's, actually not a bad thing. So now the question is, what would be a test that was a little bit more interesting? Okay, so let's make partition test 2. Okay, and we'll use the structure of partition test 1. So we copy this whole method, paste it, partition test 2. And partition test 2 will have it be the simplest imaginable array it'll be of size 2. Okay, and we're going to hope that what it does is it places the 1 to the left of the 3. Okay, and that will be it. And of course, what's the P and the R? That's a good question here. I would say that I want P to be 0, R to be 1, because 0 refers to the start of the partition and R refers to the end of the, start of the portion of the array that we're partitioning, and 1 refers to the portion of the array that we are partitioning, the end of the array that we're partitioning. Now, there's a little complaint here that we're not using partition test 2. That's fine. That doesn't worry me. So I then call partition on AR, P, and R, and the expected result is going to be 1, 3. If I can enter that correctly. All right. And now we have a great opportunity to run this because this is sufficient. We now have an expected that's different than the input, but we know that partition doesn't do anything right now. And so we would expect there to be no errors, but we would expect there to be a failed test. And when we run, we don't see a failed test. That's because partition test 2 doesn't get invoked. Okay, that's fine. That's easy to fix. We put in partition test 2. Yeah. Yep, and it didn't work. That's great. It's good news that partition test 2 failed because we would expect partition to fail at some point, given that it is a completely stubbed out function. Now what I'm going to do is I'm going to open up Caramelizers and Invest and look at the definition of partition. And what CLR calls for us to do is it says X is equal to A of P. All right, so I'm going to code that up exactly like it's in the book, and we'll just see whether or not this matches. So that's basically picking up the pivot value is X. I intend to change the variable name. So X is what we call the pivot value, named horribly. So we're gonna improve on this on what CLR has. I don't know why they don't use a reasonable name there. And then I is equal to P minus 1. That makes me nervous. And J is equal to R plus 1. I do not know why those variable values are set to those. It makes me anxious because I'm anticipating that those correspond to the indices into A that we're interested in getting at. I don't know. We'll see. Okay, we'll see what they do. And so what they do is they run forever, ultimately returning a value. Okay, so it looks like the expectation of partition is that it does ultimately return a value. Goodness gracious, why? I guess they just want to return something, so we'll just do a return. Okay, so disturbingly, the partition function has a while true, okay, and it's going to do, the pseudocode says do repeat j equals j minus 1 until a of j is less than x. And so I would rewrite that as saying while a of j is greater than x, so while an element in the array is bigger than the pivot, okay, we're going to do a thing. And what we're going to do is we're going to decrease j. Okay, so this is a little bit unwieldy. All this semicolon isn't really necessary, so I'm just going to do j minus minus. So this is a case where, so this is just decrement j until we hit a value less than or equal to the pivot. Okay, and that sort of makes sense. So as long as a value is greater than the pivot, then we're going to leave it alone. Okay. Then we're also going to be incrementing I from in the other direction. So while a of I don't think it's going to be j. I think it's a of I is less than x, we're going to increment I. Okay. So we increment I until we hit a value greater than or equal to the pivot. Okay, and so that's basically making it so that I and j proceed towards each other until they hit something that needs to be moved. Okay. Now then, if I is indeed less than j, so if we haven't crossed ourselves, then we're going to swap a of I with a of j. So I'm going to I have to find a new method that swaps the elements that I and j, and otherwise I'm going to return, and CLR returns the actual value j. I'm going to see whether or not that causes me trouble. My plan right now, oh, I guess I do need to return. What they say is they return j, and the reason is the way that they implement quicksort is that uses the return value of partition. So I'm going to make it so that partition does indeed return an integer. Now that means in turn that I'm going to have a problem in my test code. Does it? Actually, it doesn't, because I do drop values on the floor, but so here on line 24, for example, I call partition, but I don't try to use a value from it, and not using a value returned in Java does not typically cause a problem. So good news, partition has been modified in a way that should work. Why is partition test unhappy? Partition test 0 is never used. Okay, that's fine. I'm not worried about that. So let's go ahead and run. Let's see whether or not this works. Oh, bad news. We didn't implement the swap method. Okay. And Corman Liserson, actually Corman Liserson best uses pseudocode to do the exchange. But we actually need a method that does a swap. So what does that mean? This is going to be static. If I can spell static correctly, static void swap, and it takes an array of integers, an index I, an index j, and all we're going to do is exchange them in the standard mnemonic. Int temp equals a of I, a of I equals a of j, and a of j equals temp. Okay, that's the standard three lines that swaps values. This is assuming, for the time being, that the indices assumes no indices out of bounds. Perhaps at a later time we'll go in and clean that up. And so now let's see whether or not this compiles and runs. So it has an exception. How's it? It gets the old index out of bounds, index 1 out of bounds for length 1 in partition test 1. Okay. Oh, that's because in partition test 1 we have an array of size 1, and so it's not happy with an array of size 1 when p is 0 and r is 0. Interesting little issue. Now the possibility, there's a couple of possibilities here. One is that the algorithm that Corman-Liserson and Revest give us is incorrect for arrays of size 0, of arrays of size 1, or the meaning of the swap isn't quite the same. That seems wrong, or we've made some kind of mistake. But let's think through what partition does with an array of size 1. The arguments are going to be 0 and 0, right? Is that what we pass for partition 1? That's true. So the start is 0 and the end is 0. And okay, so that could be against the intended use of partition, because I is going to be p minus 1. J is r plus 1. So I becomes negative 1 and j becomes 1. And then the first thing we do is we check a of 1. That will indeed be an index out of bounds error. So there's no question that we have an index out of bounds issue here when we shouldn't. I'm a little puzzled about what to do about it, because we should. So here's an interesting thing. One component of coding is that you don't just code. You have to stop and you have to think. And so for purposes of a video where a big part of the input is me talking, I'm trying to talk through my thinking, but that's a little bit hard. But I'll do what I can here. So when P and R are both 0, then the partitioning algorithm should presumably stop. And indeed, I think that the expectation is that we don't partition an array of such a size. No, I don't see that failing. Actually, I'm not sure I agree with that. I think that is. Oh, it does. Oh, yes. The quicksort algorithm, as used by Corman-Liserson and Revest, assumes P and R are not the same. And so, fair enough. If our use case of P and R being unequal means that we have to do a special case of if P is greater than or equal to R, then we're going to return, and I guess what should we return? I guess we'll just return R, and I think that will match, that matches what J would be. J is just whatever R was after we incremented. I don't know if I want to return R plus 1, even though we do immediately go to R plus 1. I guess I'll return R plus 1. So this is to be consistent with the code below, but I worry that that's going to be an issue later on. But this should cause our current test cases to work, I think. I don't know. Let's find out. Let's run. And so we have error in partition test 2 now, index 2 out of bounds for length 2. Okay. So the good news is that partition 0, is this partition 1 or partition 2? It's partition test 2. So partition test 1 appears to have run without crashing, but partition test 2 has crashed. And now the question is whether or not P being 0 and R being 1 specifies the partition, the array to be partitioned as we wish. And that's because, and it's not, again, 3-1, though, that should be something that does indeed partition successfully. We should be able to pass the array 3-1 with the appropriate P and R. So line 36 should work, but maybe we want P and R to be different values than 0 and 1. It's conceivable that we would want R to be 1 out further, or for P to be 1 in further. The way the partitioning algorithm works is if we have an array of size 2, then the first index we check for A is going to be of R plus 1. Okay, well, that suggests that R should be 0. That seems wacky. Okay, and A of I less than X. Yeah, I'm starting to think I need to stop this video now because so this is a point where I believe that the student should review this. I need to review this, and I think that just trying to think it out on video is not going to be all that useful. So I will stop now, and then we'll come back. There won't be changing any of the code before I come back, but I do need just to think about it some. So I encourage you to think about it. What's going on here? We're getting an error right now in which we're getting an out of bounds exception. That's not surprising because of the way that partition is set up, where the first on line 74 we're accessing A of J. J is R plus 1, and R, the way we're doing it, is 1 for an array of size 2. And so if we access the array at location 1 plus 1, that'll access element number 2, and that will be an index out of bounds error. But I cannot think of right now what a better choice is for what the indices, what P and R should be in order to cause this code to run correctly. The possibilities that occur to me are that the Corman lines in reverse don't expect you to get an error when you access out of bounds in the array, and that it's just going to, that this comparison is going to return the right thing, or it's going to be the case that the choice of indexing is not what we expect. So I'm going to investigate those two possibilities and come back and talk to you about it.